right, so today for class today, we're going to center in on subtraction. Subtraction at the primary level. Subtraction at the primary level. All right, so let's think about our teaching progression. Remember, what's the theme in here? Hopefully you guys can do better than the intermediate class. What's the theme in here, Jess? Teaching from scratch. The theme in intermediate is adding tools to their toolbox, because many of the concepts they already know how to do, and we're going to be expanding on them. Well, here we don't have a whole lot of expanding to do. Here we have to start from scratch. Here, when we're talking about primary subtraction, we have to think in that way, think in that regard. How do I teach subtraction from scratch? Okay, so I want you to think that way. How do I teach subtraction from scratch to first graders? All right, have they been, well, I guess I'll use the word exposed. Have they been exposed to some subtraction in kindergarten? Yes, kind of flashcard level. They've certainly not done any borrowing. Okay, and that comes, by the time they really start doing subtraction, is second grade. First graders, we're going to be teaching it from scratch, if that makes any sense. Because we have to get them to understand what takeaway is. And then we have to go from takeaway to actual subtraction terminology. So, step one, terminology. Remember, we're teaching from scratch, so that means I'm not building on a foundation. I'm digging the foundation and starting the foundation, and I'm building the foundation. I'm not building on it, I'm starting with it. So approach your primary math class with the idea that you're teaching from scratch. All right, so terminology. Minuend, subtrahend, difference. Are those first grade words? No. Do they have to eventually become first grade words? Maybe not so much, but they definitely have to become second grade words. Do they have to become first grade words? I think so. Obviously not at first, we're not going to be doing subtraction. So we are teaching subtraction quite literally from scratch. Now your addition terminology, add in, sum, those are pretty small words, but minuend, subtrahend, now they're going to know the word difference, but they're not going to know the other words at all, and they are rather large and multi-lettered and difficult to spell and even difficult to pronounce and remember. So we will be introducing subtraction terminology from basically nowhere. No context for the word minuend is there. Subtrahend, we can at least talk about subtraction. So we have to even begin our subtraction terminology with the word subtraction itself. Add is a verb that primary students have used in other contexts. Subtract is not a verb that they have used in any context, have they? Maybe kindergarten, depending on who the teacher was, how far they went, and how much they remember over June, July, and August. Okay, so you are teaching subtraction from scratch, so you have to begin with terminology, and that goes all the way down to the word subtract itself. Subtract is takeaway. So even before I use the terminology, I have to skip ahead to concept. So, well, in between we have facts. What are the facts of subtraction? They are the subtraction families. And the subtraction families are based on the minuend. So when I learn the one subtraction family, I'm learning 1 minus 0 equals 1, and 1 minus 1 equals 0. Not a whole lot in that family. Okay. Do we have any twins in the subtraction flashcards? No. We can reverse add-ins. Think about it. With addition, we have, if I have addition problem, let's say I have 3 plus 4. My terminology is add-in, add-in, and then my answer is the sum. If I have a subtraction family, let's go ahead and do 4 minus 3. I have a minuend, I have a subtrahend, and then I have the difference. With my addition family, I learned the sevens, which is based on the sum. That's the 7 family. Those two are twins in the 7 family. All right. In the subtraction families, I'm going to name the family by the minuend, not by the difference. Okay? That way, I am relating subtraction to addition. And many times they'll be taught at the same time, not at the same time, but shortly thereafter. So with our facts, we group our subtraction families by the minuend, not the difference, which is different from addition, where we group by sum. And then look at the terminology. What do you know about addition? Okay, you're the teacher, so you need to understand all the principles that underlie that, because we are going to have to skip ahead to concept. All right, we're going to start here from scratch because they don't know the word subtraction even. Okay, so we are skipping ahead to concept and we're teaching them what subtraction is. We are getting the idea of takeaway. And we are teaching them the word subtract as a verb and subtraction as a noun. We have to start using those words. But we don't start from the very beginning. We start with takeaway. What is 4 take away 3? Or even simpler, what is 1 take away 1? And you're going to be using manipulative. So you're going to skip ahead to concept. That's usually the case when you are teaching from scratch. But subtraction from scratch is harder than addition from scratch. Why? Look at the terminology. Even down to the word subtraction. They're not familiar with subtract as as a verb, whereas addition, they know what add means because they've used it in other contexts. They have not used subtraction in other contexts. So do you see what I'm going back to every time we talk about this, a different topic? We are teaching at primary level from scratch, and you have to think of that. Okay? Hopefully the books, your textbooks and your materials or your curriculum are going to help you with that. But don't assume they know words. We're going to do subtraction today to the 6-year-olds. Okay? So, terminology has to, you can't just introduce it and certainly not review it. 5th graders, we don't have to spend time on this. We use it, we bring it up, and so forth. But we're not teaching it from scratch. So then think about, as the teacher, you're skipping ahead to concept. So think about the idea of why we have twins in addition, and actually, eventually, we won't really even notice much difference between 3 plus 4 and 4 plus 3. As a college student, you don't pay any attention to 4 plus 3 or 3 plus 4. You don't care which way you say it even. But that's not the case with subtraction, is it? What principle of addition tells me why I can reverse the order of the add-ins and not reverse the order of the subtraction numbers. And look at the terminology. Do we distinguish between the two numbers being added? No, even the terminology backs this principle up. Can we switch? Do you see you have different names? So these are specific different numbers that cannot be reversed, cannot be written any other way. Here, eventually it doesn't matter. This is called, does anybody remember the name of this property? Property that says that the order of the addends does not affect the sum. Commutative property of addition. That's true. Addition is commutative. Obviously, you're not going to teach that to your second graders. We do teach it to our sixth graders. Okay? The commutative property of addition states that the order of the addends does not affect the sum. As a matter of fact, we don't bother to give them different names, do we? That's concept behind teaching addition from scratch, and now concept behind teaching subtraction from scratch. The very terminology reflects the fact that subtraction cannot be reversed. Subtraction is the only word in the subtraction terminology that they've heard before is probably this guy, right? And it's in the wrong, it's in a totally different context. So subtraction from scratch begins with being aware of their unfamiliarity with even the word subtraction and the verb to subtract. So we are going to skip ahead to concept, start dealing with takeaway, progressing it to subtraction by manipulatives and using the words, emphasizing the words. Are they going to spell them? Not yet. All right, but you have to start using the words and having them say the words, not spell them yet, and understanding that this is going to be a lot different than addition. No pun intended. But that is also that they're used to the word difference in a different context. So subtraction terminology is going to be key for you in first grade and second grade. All right, even our second graders, we need to go back to the very foundation of the subtraction and not just jump into borrowing, and which you will do in first semester. A lot of going back and reteaching. And this is true in every teaching circumstance. All right, you remember Ab Thomas? He said, never assume. And you're more likely to assume in primary than you are in intermediate or even just the middle elementary grades. Okay, so subtraction, we have to really skip ahead to concept, and we have to spend time with manipulatives and practice understanding that subtraction is takeaway. And then we're going to always be dealing with how many are left. What is left? That's the difference. So if I ask you, what's the difference between 3 and 4? You're not going to think 1 at first, are you? And first graders certainly are not. So we already have the wrong context with the word difference. So we are teaching primary subtraction from scratch, and that includes the terminology, not just the concept. Both are from scratch. And then we will have already introduced many of the subtraction facts with their addition counterparts. So that's the second idea here. We are teaching primary subtraction from scratch, not just with concept, but also with terminology. Then we also have to, the second idea here is relate it to subtraction. Relate subtraction to addition. How is addition and subtraction alike? How is addition and subtraction different? There's that word again, different. Okay, so with addition we will relate, or subtraction, with subtraction we will need to begin our concept with what subtraction is, relate our concept to the facts we've seen before but don't really understand, and then we have to relate subtraction to addition. How is addition and subtraction the same? How is addition and think for yourself. Concepts behind what you're teaching. You are not teaching the commutative property, but it's a concept behind, it's a principle behind. How are addition and subtraction alike? How are they different? Can anybody give me one way they're alike? I'll give you a hint. We know that if we're doing addition, what else do we know about units? When we're adding with measurements, we can only add what kind of units? Is that the same for subtraction? Yes. So the first way that addition and subtraction are alike is that, like addition, subtraction follows the law of likes. You can only add like quantities, so you can only subtract like quantities. So that is one way that they are alike. Then, how are they different? Well, the first way we already showed you. Addition doesn't matter which number is which number you write on the top and which one you write on the bottom. Subtraction, you can only subtract a larger number minus a smaller number. And there's another word, minus. There's another word. We're doing all kinds of new things. So we can only subtract like quantities, and we can only subtract them in order, minuend minus subtrahend. We can only subtract a smaller number from a larger number. And so even the order is different. The order is critical. To me and to you, it doesn't matter. I can say 3 plus 4 or 4 plus 3. I can't say 4 minus 3 and 3 minus 4. So there's a distinction between the minuend and the subtrahend that does not apply to addition. That's a big difference. All right, so addition and subtraction are alike in the fact that the law of addition, only adding likes, carries over to subtraction. You can only subtract like quantities. So that means you can only subtract like units, which is be about the only thing you would do in first and second grade. But later on, you can only subtract common denominators. You can only subtract like decimal places. And you do have to line up your subtrahend and minuend by place value. Just like you have to line up, when you start expanding to new digits, you have to line up your places. All right, so subtraction is like addition, in that you can only add like quantities. So it is similar to, I'm using like and difference all over the place, aren't I? What's that going to do to a first and second grader? It's going to confuse them. So we are teaching from scratch. We have to stop and think that way. We have to think about, many times with primary, you have to think in a lot more detail about your word choice. I don't think about my word choice in Algebra 1. I do think a little bit about my word choice in 7th grade math. You're going to have to think about your word choice constantly in primary. And you're going to have to think constantly, do they know that word? Because their vocabulary is much lower than yours and very limited in mathematical terms, for sure. So how is addition and how are addition and subtraction alike? Basically in the one way that you can only add like quantities and you can only subtract like quantities. They're much more different, and so there's going to be more of a contrast. So we cannot We cannot interchange at minuend and subtrahend. We cannot change the order. But we do still need to relate the two together. They're alike, but they're very different. But they are closely related. How are they related? They're alike, they're different. Now, how are they related? The principle behind this all centers around the word inverse. What does inverse mean, mathematically speaking? Pardon me?
Opposite.
It means opposite with respect to addition and subtraction. It is the opposite operation. It kind of reminds me of the word reverse. Addition is reversed by subtraction, and subtraction can be reversed by addition, but reverse is not a mathematical term. Inverse is the mathematical term. They are inverse operations of each other. Later on, Brooke, that word's going to take on a more specific aspect with positive and negative numbers. But right now, I suppose it can be used. It's opposite operation. The correct word is inverse, but is inverse a first grade word? Is it a second grade word? Is it a third grade word? It needs to be starting to be introduced, but that's going to be introduced later. But you need to realize that they are inverse operations of each other as the teacher, even though you will never say that word. Okay? So do you get the idea more and more as we go through this semester what I mean when I say you are teaching from scratch? That really relates to subtraction with primary grades, much more than addition. Well, it's true you're teaching addition from scratch and place value from scratch. But to me, the subtraction at second grade was a real big deal, and then so the subtraction at first grade is a really big deal. Because addition is a lot more familiar even to your first graders. Because the terminology is easier, doing it in real life is more common, and so forth. Okay? So then we have to center in, skip over to concept. But then we also are going to spend a lot of time with our addition facts. Last semester, when we were dealing with mostly third graders, fourth graders, fifth graders, dealing with the middle grades that already had a basic foundation, we weren't as concerned with basic subtraction and addition facts, were we? We were concerned with learning those times tables in grade 3. Learning the times tables in grade 4. But in grade 1 and 2, you have to be very concerned with learning the addition and subtraction families, so that when they get to grade 3, they already have most of those down pat. So for grade 3, you can concentrate on the times tables, okay? So primary subtraction involves parking on the concept and making sure they know the terminology, introducing the terminology, using the terminology, introducing all these words that they don't have a context for, and then spending time with manipulatives on takeaway. A lot of time with manipulatives on takeaway in first grade. Then, as we are doing this, we are going to be working during drill on facts. Addition families, subtraction families. They don't really start learning the teen subtraction families until the end of second grade. They've seen them, but they don't know them. All right, so drill time in primary is a lot different than drill time in intermediate, and even different than elementary, okay? In intermediate, I think it's important for them to spend a lot of their drill time on mental math. We were dealing with prime versus composite today in intermediate math. And I told them they should use that in drill time. They can even start taking flashcards and put the number 8 on a flashcard, and then train their students to be able to prime factor the smaller numbers mentally. 8 is 2 cubed, right? 9 is 3 squared. 12 is 2 squared times 3. That's something that you can start pushing your students in 6th grade to be able to do, pushing 7th graders to be able to do. So in your intermediate, it's an entirely different approach to drill than it is in primary. And even those middle grades, grade 3, 4, 5, that we did last semester, the drill for grades 3, 4, and 5 is entirely different than the drill for grades 1 and 2. So subtraction facts and addition facts have to really be mastered and drilled to the point of being automatic. Think about trying to teach your 2nd graders how to borrow. They're going to be using their brain to try to grasp the idea of borrowing, to grasp the idea of what's really going on, because I'm borrowing a multiple of 10. By moving that little 1 over, I'm borrowing 10. I'm concentrating their mind on that. Do you want to be distracted by the fact that we don't know the addition fact, or sorry, the subtraction fact behind it? We're busy trying to learn how to borrow, and then my student doesn't know that 13 minus 5 is 8. What's that going to do? It's going to cause the whole concept of borrowing, the whole procedure of borrowing, to be a disaster, because they can't do the fact that goes with it. So I'm trying to teach them how to move the 1 over next to the 3 so that I can subtract it, and they don't know the fact. So they're struggling to come up with 8 or 5, whichever way I do it, and that's going to just cloud the whole issue of the borrowing anyways. So facts have got to be drilled, drilled, drilled. Practice at home, flashcards at home, writing them, reciting them, so that when I finally get them to understand, let's say I have 92 minus 65. I'm trying to get them to take 10 from the 90 and put it in the ones column, so that I now have 12. We're working on that borrowing, but then what if they don't know 12 times 5 is 7? Are they going to be able to do the borrowing? Because they don't understand the concept? No, because they don't know the bare bones fact that 12 minus 5 is 7. Okay? So you've got to drill, 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 drill those subtraction families. And then relate those subtraction families to their addition counterpart. Otherwise, when we're at the middle of 2nd grade and they've got to figure out the borrowing, they're going to have a really hard time. And they're going to think it's hard because they're fishing around in their mind for that 7. And they can't concentrate on what they're doing with their borrowing. Have you ever had to fish around in your mind for a math fact? Maybe during a long division problem and you just can't think. 54, is that 7 times 8 or is that 9 times 6? Okay, so that's what I mean by this is an entirely different approach. You are doing a lot of concept teaching. You have all kinds of things in your classroom all the time. I told you about Mrs. Leslie's box, a little jar of bugs, little plastic different colored beetles and butterflies and grasshoppers. You've got to have a lot of hands-on materials. Maybe you bring in rocks. Maybe you bring in fruit from the kitchen. Maybe you bring in whatever you bring in. It doesn't have to be something you purchased. It can be whatever. Lots of manipulatives so that you are concentrating on understanding the takeaway. And then you're going to have to relate the borrowing to the addition counterpart. So borrowing is the major subtraction procedure, just like what was the major addition procedure we covered last time? What is it? Carrying. Okay. And I mentioned last time I'm going to have Mrs. Brader show you the carrying techniques and the place value techniques. And so what we've got to do is we've got to make sure we can carry efficiently and we understand carrying, then we can go to borrowing because it's still involving that place value idea with the straws and the cups and so forth. So borrowing is the major subtraction procedure. But with primary math, the main thing you've got to begin with and solidify first is what is subtraction. Then what are the words they're going to be hearing about subtraction? So subtraction from scratch is a big part of primary mathematics. Learning the subtraction families and the addition families are a big part of primary drill. And you want those families to be automatic so you can concentrate on the borrowing procedure. Okay, so that's going to be very important for your students, and it's very important for your approach. Okay, so subtraction. Teaching subtraction at primary level is from scratch. Now let's review borrowing at your level. Okay, let's review borrowing from, I had you do 1.1, 1.2, very easy type of actual arithmetic. Subtraction. As a primary teacher, you're probably not going to be as concerned with your own math skills because you're going to be concentrating on theirs. But that doesn't mean you can have issues with your own subtraction skills. So let's review borrowing kind of in a backwards manner. Let's start with your borrowing and work it back to their borrowing. Okay? So your borrowing should be without thought. Okay? Your borrowing should be without thought. You should be able to easily do it, but probably you're a little rusty on basic whole number subtraction. So a couple of things as you do your subtraction review homework with your own borrowing. Probably out of all the whole number computations, we have the most trouble with dumb subtraction errors, and most of the problem there is with missing facts. The other thing that you might have as a college student with your basic arithmetic skills is making dumb mistakes in long division. Okay, so those are going to be the problem areas, especially the long division. But at the same time, make sure that you can do the borrowing yourself without thinking. And so that way we can work our way backwards from your subtraction skills down to how to teach them their subtraction skills from scratch. So basic borrowing involves place value. So if we just take a regular problem here, most of the time at upper elementary, and for you guys, we are going to do at least 4 digits, maybe 5 digits. So let's do 8,925 minus 6413. What do you notice about this very first borrowing review problem? I mean, not borrowing review problem, I just gave it away. What do you notice first about this subtraction review problem? There's no borrowing. So as we review your skills, let's think about their skills as we go. What this problem brings to my mind is, obviously you can do this, and it is a good first problem because there's no borrowing. All right, so as we apply it to your teaching, let's think. I want to think backwards. We might begin our subtraction review with this problem. This problem should give you something to think about with respect to teaching it from scratch. So remember that when you are teaching subtraction from scratch, there's a couple things that this problem reminds me of. Okay? We're only going to work with 2 places for a long time when we're teaching borrowing to second graders, right? And we have to introduce it again. When we add the hundreds place, our third digit, we have to reintroduce our borrowing and go over it again. I don't know about you, but I would so automatically, doesn't matter to me what place I'm borrowing in. Does it matter to you? No, it will matter to your second graders. So you can't just expand the problem. Remember, we're teaching from scratch. You can't just expand the problem from 2 places to 3 places without teaching it and without stressing to them that we're still borrowing a 10, even though we're borrowing hundreds and whatever. So this introductory problem at college level reminds me that we are going to only do 2 places for a long time in primary math. And it reminds me that when I teach primary subtraction, I have to introduce the next place. Here's the thing. They're not going to expand on their own. You're teaching primary. All right, so you're teaching from scratch. That means they don't automatically expand to the next digit over. My 7th graders do. The 6th graders do. The 5th graders do. The 4th graders do. The 3rd graders might need a review, okay? But the 2nd graders have to be retaught the borrowing with each new place. Remember, what are we doing? We're teaching from scratch, okay? And so I'm trying to remember all the problems that I had. And so this problem reminds me that we're going to stick with 2 places while we're teaching our borrowing. And then when we expand, we will reteach, completely reteach, go from square one with the hundreds place as if they never saw the tens place. And then we put the 2 together. So they do not expand on their own from 1 place to 2 places, from 2 places to 3 places. Keep that in your mind because you can subtract anything, right? They can't subtract. You can subtract anything. You can subtract decimals, you can subtract fractions, you can subtract whatever you need to subtract. Keep in mind that you can subtract anything. They can't subtract anything. So all we're going to do is add a not. So you can subtract whatever you need to subtract. You use it all the time. You use it in all kinds of different contexts. They have no context for subtraction. They can't subtract. So you do not assume they can expand the concept. So I have 2 places on the board and 3 places on the board, but it's even true with 1 place. You can't subtract 1 place. You can't teach 1 place subtraction without teaching them about 2 places and 3 places. So they do not expand on their own. You teach each new place, okay, as a new concept. All right. Then the other thing this reminds me of is that I begin my extra places with no borrowing. So even the authors of your college review textbook started you out just subtracting without borrowing. Even they did that. So no borrowing when you are going from 1 place subtraction to 2 place subtraction. And when you're going from 2 place subtraction to 3 place subtraction. They do not expand on their own. You teach it from scratch. So no borrowing. That reminds me to what we said about, remember in our teaching progression, we have terminology, we have facts, we have concepts, and remember I told you sometimes they're not in that order. Those are just processes, and depending on what you're teaching and who you're teaching, you may change the order. What was number 4? It's not any particular order. Number 4 was procedure, right? What did I say about procedure? What phrase do I want you to remember? One at a time, please. So this really applies. This applies a lot. One at a time, please. Even yesterday in my college class, I was noticing I was doing information overload. Okay? And so you can't do concept overload or procedure overload when you're teaching at any level. And the whole point here is you never want to do it. You never want to do it in 5th grade math, too much at a time. You never want to do it in Algebra 1. But you really, 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 really don't want to do it in 1st grade. One thing at a time. Okay? So that's what this problem reminds me. I do one new thing at a time, especially in primary. You should always do it on every level, but the problem with primary is everything's new. So keep that in your mind and keep it in front of you when you're preparing. Have the idea that everything is new and teach it in that perspective. One of the worst faults of a new teacher is just that, assuming they already know it. So if you're a primary teacher, you've got to constantly remind yourself that everything is new, so one at a time, please. If you overload them with too many procedures at once, nothing will be understood or mastered, okay? You've probably heard the phrase, jack of all trades, master of none. That's really true of mathematics, especially at primary level. Okay, so here's our first review problem. What can we learn from it? This reminds me that this is primary. One thing at a time. This reminds me that I cannot expect them to expand on their own. 7th graders, we want to start, that's part of the problem with 7th grade math. They're not used to doing expansion on their own. And so they're very poor problem solvers. So we have to work on that later. But right now, we don't expect it at all. Okay? So this problem is easy. There is no borrowing at all. Another thing that you will notice, common procedure now, is on a 4-digit number, no comma. Okay? So actually you're not going to see this except probably at primary. By the time you get in other levels, the comma is not used until we are another place out. If this was another place out, then we start using the comma. So the new rule of thumb with comma separating into periods is that you do it after 5 places, not 4, even though technically there would be a comma here. Because the purpose of commas in dividing into periods is for ease of reading. We don't really need it for ease of reading here. But the bigger the number is, the more important the commas become. So you'll notice in this textbook, they never put a comma in a 4-digit number. They start the commas after 5. So a little explanation there. So then, with subtraction, often we make borrowing errors. So then, the next example in our college book looks like this. Take a look at that problem. As a teacher, you've got to learn how to choose example problems wisely. Especially as a primary teacher, you're going to choose your example problems wisely. You're going to remember the one at a time principle of how to teach procedures. And then notice this problem. Even in my college review book, do you notice I went back to 3 digits? Okay. And the next thing I notice is that this subtraction problem only has 1 borrow. So the next thing that I'm going to be expanding to is sequential borrowing. So this reminds me, wait a minute. Not only do I have to learn how to borrow, in the tens place, from the hundreds place to the tens place, I have to learn how to do more than one borrowing in the same problem. So here we are again. As I'm teaching the borrowing, I'm going to do not only one step at a time, I'm going to do one borrow at a time. So it's another concept to be able to teach them to borrow in sequence. So notice this next problem. It reminds me that do one place at a time as well. That sequential borrowing is a new concept, and it has to be separately addressed. So look at this first problem. This first problem only has one borrowing. So this is literally the 90, and I am literally borrowing 10 to make my 212. And then once I do this, I don't have to borrow again. That's what I mean by sequential borrowing. So when you're teaching borrowing, that's a new concept, to be able to borrow 2 times in a row. And then the other thing that happened, and all of these can be problem areas. So do you see your approach with primary math? Okay, I know you know how to borrow, and almost the better you know how to borrow, the worse you're going to teach it, in one sense, unless you stop and think through. Problem choice has come back to bite me a lot of times. I'll put it on the board and all of a sudden I realize, oh, that's got a quirk to it. Even in algebra class, well, that doesn't happen to me too much with algebra, but it did at first. All of a sudden I'd put something on the board and it didn't factor right. I was like, oh, wait a minute. I don't want to use that for example. I have to cover that later. So you're going to have to really watch out for that. You're not going to want to use something as an example that has a quirk to it or that has an extra step to it. And the lower the level is, the more quirks come up without you thinking about it. I told you when I taught borrowing, I made a mistake more than once of putting a problem on the board that we hadn't finished learning all the families on. So I had to remember to keep my minuend small so that I didn't have to borrow, or I didn't have to subtract 15 minus 7 when we were still learning the 14s. So all of those things came back to haunt me a lot. So you do have to be, when you're making up your own problems, it is time consuming. When I make up my own problems in algebra, I actually even make a list of exactly what I want each problem to do, so that I don't get caught by making up a problem that has a quirk to it. Are you going to be teaching problems that have, are you going to be using problems to teach that have extra little weird things about them? No. So I am not going to borrow something with a big number here like 15 minus 8. It's safer for me to use 12 minus 8 as my fact. So all of those things you have to pay attention to. And every once in a while your curriculum will have a mistake in it. They'll have a problem that's too far advanced for where they are. So you have to be aware of it. Because then all of a sudden that causes confusion. They see that problem, they don't know the fact that goes with it, and then they get the misconception that borrowing is something they can't do. All right, and so you have to be careful with that. So this next problem shows me that when I am teaching borrowing, I have to do one thing at a time, and I have to be very aware of each new thing has to be taught. Don't assume anything. So even in this college book, what can I learn from their second example is that I'm going to teach borrowing one place at a time, and then I have to address the sequential borrowing. Okay? Because sequential borrowing is when you have to borrow in more than one place. And then some sequential borrowing is you have to borrow from the next place over. So each one of those circumstances in borrowing, I have to be aware of and address them, not just put a problem on the board and oops. They have to go all the way over to the hundreds place. Okay, so what happens if I have zeros? So that's my other thing I have to address as a separate procedure, how to borrow with zeros. Okay? How to borrow sequentially, then how to borrow with zeros, then how to borrow with all zeros. Okay, let's do it. Let's think of a problem that has sequential borrowing. What if I have 322 minus 176? Sequential borrowing is I have to borrow here and here. And then other times, what if I do this? Put a 0 in the middle. Then, what if all of them are zeros? These are all separate procedures. Probably in second grade, you're not going to be throwing so many zeros at them. And so this has to be addressed again in what grade? Third. Are you going to assume they know how to borrow? In third grade. It's a new concept in second grade. It will be retaught in third grade. If you don't reteach it in third grade, you're going to have problems. You're going to have good students that can borrow, but you're going to have a lot of your students that can't borrow. And so you have to also in third grade realize, okay, borrowing is a huge deal. I got to make sure that I cover each circumstance. So then as you're doing your own subtraction, you better watch out for the sequential borrowing. You got to really watch out for the inserted 0. And this one is actually a little harder than that one. This one, all you got to do is what? Make it 299. You can just plop it over. Even if I had 5,000, you just, throw those 9s in, right? What about when you have this? You have to make this a 29, right? All at once to get your 12 to borrow from your 6, and then you're good to go. All right, on this one, the sequential borrowing is where you do separate borrowing in a row. But when you start throwing the zeros in, or even sometimes 1s, if you borrow from a 1 there and there's nothing left, you're going to have to sometimes skip over a place to borrow. See? You're skipping over a place to borrow. Here you have two separate borrowings. So what do? We just do one at a time. We're going to borrow 10 from the 20, make it a 10, make it a 1, and then we have to do, that works for there, but then I have to borrow again, borrow 2 times in a row. And that makes that an 11. Now, all this borrowing causes numerous mistakes. So subtraction is the opportunity to introduce checking. We can check addition by reversing the order of it, but we don't deal with that a whole lot. So when you do when you start doing some heavy-duty borrowing, it takes 2 seconds to add back. In fact, you can even do it without rewriting it. 6 plus 6 is 12, carry the 1. 8 plus 4 is 12, carry the 1. I got back to my menu N when I I got back to my menu N when I added back. So it's always a good idea with multiple borrowing and zeros in borrowing to even for yourself, go back through. 8 plus 2 is 10, and make sure that, because this is 4, this is 2, this is 1, I can easily go back through and make sure that I get 300 or 302 or 322. Okay? So borrowing is the most important procedure for primary subtraction. Lots of time, lots of practice, lots of drill on subtraction facts. All right, we'll see you on Friday. See you on Friday.